Now we are discussing about biological oxygen demand. It is nothing but BOD. Before going to BOD, we just know about the DO is nothing but the dissolved oxygen, that is the dissolved oxygen DO. Coming to the DO, the amount of oxygen dissolved in the body of water such as lake, river or stream is known as dissolved oxygen. Dissolved oxygen is the indicator of water pollution. Dissolved oxygen in natural and wastewater depends on chemical and biological activities in the water bodies. Amount of oxygen that can be dissolved in water by temperature. It is usually determined by Wrinkler's method known as iodometric method. It is discovered by Wrinkler, then it is called as Wrinkler method. It is also known as iodometric method. Iodine is used in this method, so that it is also known as iodometric method. This method was developed by L.W. Winkler. Principle. Behind this principle, the basic principle in this method is that DO reacts with manganese ion to form manganese dioxide. Here equation you observe that Mn2 plus oxygen plus hydroxyl ion gives rise to manganese oxide plus water molecule. This is the reactive molecule by the formation of manganese react with oxygen leads to the formation of manganese dioxide, which manganese dioxide further react with iodine ion, that is we are using iodine indicator. This iodine ion to liberate iodine in an amount chemically equivalent to original dissolved oxygen. Here second equation we observing that manganese dioxide plus iodine ion plus proton molecule gives rise to manganese plus iodine plus water molecule. This liberated iodine is titrated with sodium thiosulfate. Here Na2S2O3 is the sodium thiosulfate. Iodine plus sulfide molecules gives rise to iodine ion plus sulfate molecule. Here this liberates iodine is titrated with sodium thiosulfate. This liberated iodine concentration is titrated and calculate the amount of iodine liberated. The main principle behind this is liberated iodine molecule is calculated. Next, reagents used. Reagents used is manganese sulfate, alkali iodine. This is the main reagent, is nothing but the iodide, alkali iodide, azide reagent, sulfuric acid, starch indicator, standard sodium thiosulfate with the normality 0.025 normal standard sodium thiosulfate. Next, coming to the procedure, here we are observing different steps. This is the modified Wrinkler method. In this method, first step, BOD bottle with filled sample. We are observing BOD bottle. This BOD bottle consisting of lid. We are open the BOD bottle lid, and this BOD bottle filled with water. Add 1 ml of manganese sulfate To this BOD bottle, add 1 ml of manganese sulfate, and then to this bottle add 1 ml of alkali iodide azide solution. We are adding 1 ml of manganese sulfate and adding 1 ml of alkali iodide azide. Replace the stopper and shake to mix well. Here, after that addition of manganese sulfate and alkali iodide azide, after that shake well this BOD bottle. Then after shaking, then add 1 ml of sulfuric acid and replace stopper and shake to mix. Again shake well the bottle for the mixing of total reagents. Next one, titrate to 20 ml of sample in Erlenmeyer flask and then add starch indicator. This is titrate is nothing but the titrated against sodium thiosulfate solution. After that add 1 ml of starch indicator. Blue color should develop. Before the addition of 1 ml starch indicator, we can observe pale pink color, pale yellow color. Okay, then 1 ml of pale yellow color, then add 1 ml of starch indicator. Blue color should be developed. Then titrate the sample until the colorless solution. Now the calculation, now the reading is observed, different titrations, and then average the reading of the particular titration reading, then calculate the particular reading with the following equations. Calculation: if the whole content is used for titration, then dissolved oxygen mg per liter is equal to V1 into capital N into 1000 divided by V2 minus V3. Here V1 is nothing but the volume of titrate, is nothing but sodium thiosulfate. V2 is nothing but the volume of sampling bottle. V3 is nothing but the volume of manganese sulfate and potassium iodide solution added. Next one, here we are observing N is normality of sodium thiosulfate is nothing but the 0.025 normal. Next, when only a part of contents have been used, then DO mg per liter is equal to V1 into N into 8 into 1000 divided by V4 into V2 minus V3 divided by V2. Here V4 is the volume of parts of content titrated. Here DO levels, we observe the water quality and DO levels. Good quality is nothing but the 20 degrees centigrade sea level. Good quality is nothing but the DO levels is 8 to 9 parts per million O2 ppm. Then moderate pollution 4 to 5 ppm O2. Highly polluted below 4.5 ppm O2. Dissolved oxygen, here we are observing the tables, that is the dissolved oxygen mg per liter at saturation in fresh water. 0 degrees centigrade, we are observing 14.6 dissolved oxygen. 5 degrees centigrade, we are observing 12.8. 10 degrees centigrade, 11.3. Here we are observing the increasing the temperature, decrease in the dissolved oxygen in fresh water as well as sea water. Next one, coming to the main point, that is the biological oxygen demand. BOD is the amount of dissolved oxygen. We are also already know that the dissolved oxygen. BOD is the amount of dissolved oxygen required to break down the organic materials of the sample by aerobic biological microorganisms at certain temperature over a specific period of time. This parameter is determined with the consumption of oxygen by microorganisms during 5 days of incubation at 20 degrees centigrade. BOD indicates a amount of pollution of water bodies. Lower BOD indicates the water is a good quality for aquatic life or little aerobic activity, whereas the higher BOD indicates the water is highly polluted. When BOD is higher, then DO becomes lower. So, aquatic organisms are unable to survive at normal rate. It becomes stressed, asphyxiate, and may die. Determination of BOD. The most common and popular method for determination of BOD is standard method, which is recognized by US and EPA. It is not accurate quantitative test, although it is widely used as an indicates the amount of pollution. Procedure: take 2 samples of water, record the DO level ppm of 1 immediately using the method described in the dissolved oxygen test. Also, we are discussing about the dissolved oxygen. We are taking 2 water samples. One is immediately record the DO level. Place the second water bottle. We are taking 2 water bottles. One water bottle immediately calculate the DO level, and second water bottle place in an incubator in complete darkness as 20 degrees centigrade for 5 days. If you do not have an incubator, wrap the water sample bottle in aluminum foil or black electrical tape and store in dark place at room temperature, that is nothing but the 20 degrees centigrade. After 5 days, take another dissolved oxygen reading ppm using the dissolved oxygen test kit. Subtract the day 5 reading from the day 1 reading to determine the BOD result in ppm, parts per million. Calculation: the difference between the 2 DO levels represents the difference between the 2 DO levels represents the amount of oxygen required for the decomposition of any organic material in the sample. That is, equation is BOD mg per liter is equal to D1 minus D2 by V. D1 is the initial DO, D2 is equal to final DO, V is the volume of water sample used. BOD level and remarks. 1 mg per liter is very clean water. 2 mg per liter is clean water. 3 mg per liter is fairly water. 5 mg per liter is doubtful. 10 mg per liter is contaminated. BOD of some collected samples from different sources. Normal values, that is normal water consisting of approximately 0 to 3 mg per liter. River water approximately 5 to 20 mg per liter. Sewage water 50 to 100 mg per liter. Industrial waste 150 to 1000 mg per liter. Land for irrigation 100 mg per liter. Marine coastal area 100 mg per liter. Inland surface area 30 mg per liter. Public sewers 350 mg per liter.